Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. Today we're going to wrap up chapter 5, and we're going to talk about dividing polynomials. We're going to talk about dividing polynomials by monomials, and then we're going to talk about dividing polynomials by polynomials, and then sometimes, if we have the correct conditions, we can use a really simple way of dividing called synthetic division. So first of all, I want to briefly, I know I'm a broken record, but I want to continue to make sure that you guys understand the laws of exponents. This is the key to everything in this chapter. So if you remember, the law of exponents is a times a to the n m, let's do that again, a to the m as in Mary times a to the n as in Nancy equals a to the m plus m. Keep the same base and add the exponents. It's that simple. Raising a power to a power. Well, I have a to the m raised to the n equals a to the m times n. So when I raise a power to a power, I keep the base and multiply the powers. When I have ab raised to the n power, I'm going to distribute that outside exponent to all the exponents inside. I'm going to go ahead and multiply that n to the exponents of a and b. Remember, when you don't see an exponent, there's an invisible 1. So therefore, I have a to the n times b to the n. If I have a division within a parenthesis raised to a power, I am again going to use the power property. I'm going to distribute that n to all of the exponents, giving me a to the n over b to the n. So when I raise a power to a power, I keep the base and I multiply the exponents. I know I'm going rather quickly, guys, but this should be a review for you. Division. When I'm dividing, a to the m over a to the n is a to the m minus n. You keep the base and subtract the exponents. But remember, guys, we talked about canceling out exponents. So that's a quicker and more efficient way to do it. But this is why we're able to cancel them out, because of this property. We have negative exponents. Hopefully you guys remember that a to the negative n can be rewritten as 1 over a to the n, or 1 over a to the negative n can be rewritten as a to the n in the numerator. So when you make a reciprocal, you change the sign of the exponent. What that means is, if I have a negative exponent in the numerator, I bring it to the denominator, I make it positive. I have a negative exponent in the denominator, I bring it to the numerator, I make it positive. Okay? Then I have a over b to the negative n. That can equal b over a to the n. If I have a negative exponent, okay, affecting polynomials or monomials inside of a parenthesis, I can literally flip what's inside without changing the exponent sign, and you just change this outside sign. That's negative exponents. And last but not least, 0 exponents. Anything to the 0 power is 1. Okay? Make sure you understand, though, what the 0 is affecting. For example, if I have 7x to the 0, that equals 7. But if I have 7x in parentheses to the 0, that equals 1. Big difference. Okay? Give me 1 second, please. Okay. So, in a nutshell, those are the rules of exponents. Now, let's go on to division. In order to properly divide a polynomial by a monomial, remember the following, guys. Remember that if I have a plus b over c, that really equals a over c plus b over c. When I divide a polynomial by a monomial, I have to divide that to every single term of the numerator's polynomial. It's basically the distributive property, but of division. So when I am given something like this, they say simplify each polynomial, and I have 12x to the fourth plus 24x cubed plus 4x squared divided by 4x squared. What I am literally doing is I am dividing this 4x squared to every single term. So if you can't see that, rewrite it. This is 12x to the fourth divided by 4x squared plus 24x to the third divided by 4x squared plus 4x squared divided by 4x squared. And this is going to leave me with 3x squared plus 6x plus 1. Bada bing, bada boom, I'm done. Does that make sense? Yes, sir, my brother. Yes, you have to put the one great question because, and I'm not being sarcastic, but 4x squared over 4x squared is 1. You can't, you may be thinking, but Moro, a lot of times ones are invisible. Ones are invisible in multiplication, yes, but never in addition, my man. That's actually a very good question, my man. If I had it like this, brother, 4x squared over 4x squared times, let's say, w, yeah, this would just be w, and this one could be invisible. But since I have an addition here, I have to translate that one. Does that help? Was that the mistake you were thinking about? Yeah, no, that's very common. People will just cross it out, and that's great. But there is a 1 there. Okay, thank you so much, kid. Great job. Okay, here. Again, I'm dividing 2a squared literally to every single term. I don't see it, Mr. Morrow. Fine. Go ahead and write it out. There's no shame in showing work. Remember that, guys. There's no shame in that. So I got 6a squared b, and then 2a squared b squared, and I've got plus 5ab squared over 2a squared b squared. Okay, what is this going to leave me with? What's my first term going to reduce to, gentlemen? 4b. Thank you. Excellent. Because those two go bye-bye, take 2 from there, and I have 1b left. Excellent. What's next, my brothers? Negative 3? No, not negative 3b. 6 divided by 2 is 3, yes. A squared over a squared, they cancel. I got 1b in the numerator. I take 1b away from the denominator. I'm left with 3 over b, gentlemen. Why do you think I went over the exponent rules just 3 minutes ago? You have to know your rules, my brothers. And then last but not least, what would I be left with here, gentlemen? 5 halves, for sure. That doesn't change, yeah? A on the bottom. I take an a from the numerator, take an a from the denominator. I'm left with 1a in the denominator. And that is my answer, gentlemen. Does that make sense? Okay. You sure? Okay. Let's move on. Now, when dividing a polynomial by a binomial or by another polynomial, it doesn't have to necessarily be by a binomial. When you're dividing a polynomial by a polynomial, excuse me, remember basic division and follow the same procedure. Let me explain what I mean by that. If I were to tell you 579 divided by 16, I guarantee you that all of you will be able to do this. Oh, hello, Morrow. 16 on the outside, 579 on the inside. How many times does 16 go into 57? No. 3 times. So that's 48. Drop down the 9. 57 minus 48 is 9. Very good. How many times does 16 go into 99? 6 would be 60 and, yeah, 6 times. So that'd be 96. And then I have a remainder of 3, correct? So I could write this as 36 and 1/3, right? Right? Okay. Now you may be looking at me like saying, why is he doing this? Let's actually break this down. We asked, how many times does 16 go into 57, right? We said it went 3 times. Didn't we subtract the product and then move on, right? Okay, remember that. Then I asked, how many times does 16 go into 99? I said it goes in 6 times. Didn't I subtract the product, right? And then I had this left over. That's my remainder, right? And my remainder went over the original denominator. Actually, this should be a 16, shouldn't it? Actually, it should be a 3/16. Sorry. I don't know why I got 1/16 there. So it should be a 3/16 because that's my remainder. Everyone with me there? Hello? Promise? Yes? Okay. You can't simplify 3 and 16, but if you could, you yes, of course. Okay, now let's look at that. Let's keep that up there, and let's teach you guys how to divide x squared plus 10x plus 21 divided by x plus 7. We're going to do the same setup. Denominator always goes on the outside, so I've got my x plus 7, and I've got my x squared plus 10x plus 21 on the inside. Okay, now, do not make this difficult. Don't make it difficult. When we're trying to divide here, we are not working with the x plus 7 to begin with. We are only working with the first term of the divisor's leading coefficient. So we are going to ask the same question that we asked over here. Remember how we asked how many times does 16 go into 57? But now we're going to ask how many times does x go into x squared? It doesn't go in twice. No, it doesn't go in once. Let's go ahead and divide it and find out. X squared divided by x. How many times does x go into x squared, guys? It goes in x times. Does everyone see what I just did there? If you don't know how to do this in your head, show yourself. You with me? Now, over here in this example, when I multiply by 3, I multiply that by 3 and I subtract the product, correct? Well, let's do that. What's x times x? Okay, and then x times 7? 7x. Now I've got to subtract this product. So when I subtract the product, this goes to a negative, and this goes to a negative, and the first term cancels. If your first term does not cancel, you messed up. Stop, redo it. I promise you, if the first term does not cancel, you made an error. Stop and redo it. Now, what am I left with? What's 10x minus 7x? 3x. Drop the 21. How many times does x go into 3x? How many times does x go into 3x? 3 times. So that's 3. Distribute and subtract the product. What's 3 times x? What's 3 times 7? Distribute the negative. And that cancels, and that cancels. In this case, you have no remainder. And my answer is x plus 3. We're going to do some more examples like this, but does that make sense? Now would be the time to ask me a question. Sir, thank you. No, there's no other way to do this. It's not like you can have an either or. It's not like you can say, oh, let me divide x plus 7 to x squared to 10x and then to 21. No, that's not going to happen. You cannot do that. This is a different procedure. Okay? Let's do another one. Let's do another one. I got 6x squared plus 9x minus 10 divided by 2x minus 1. So I'm going to put 2x minus 1 on the outside. And I'm going to put my 6x squared plus 9x minus 10 on the inside. When you write your dividend, what's inside of the house, always make sure that it is in standard form. Always make sure that the dividend inside of here is always in standard form. Okay, highest exponent to lowest. Now, let's do this. How many times does 2x go into 6x squared? It goes in 3x times. Subtract the product. What's 3x times 2x? 6x squared. What's 3x times a negative 1? Negative 3x. Distribute the negative and subtract. 6x squareds cancel. 9x plus 3x is 12x. Drop the negative 10. How many times does 2x go into 12x? No. 12x divided by 2x is not 6x. It goes in 6 times. So plus 6, subtract the product. 6 times 2x is 12x. 6 times negative 1 is negative 6. Distribute. So I have a negative 4 left over. That's my remainder. So my answer would be plus a negative 4 over 2x minus 1. So my full answer is 3x plus 6 with a remainder of negative 4 over 2x minus 1. Just like in this first example that we did before with the numbers, the remainder has to go over the original divisor. Talk to me, gentlemen. This can be very simple or it can be very confusing. Talk to me, please. Of course we're going to do one more. No, thank you, son. Okay. In this case, I got a minus 9x plus 2x squared plus 12x cubed plus 5x to the 5th divided by x squared plus 3. Uh-oh. I've got to write this first in standard form, going from highest exponent to lowest exponent. Okay, you with me here? So let's do this. So I've got my x. Whoa. So I've got my x squared plus 3 on the outside. Now I'm going to go standard form. So I've got 5x to the 5th. Now, do I have an x to the 4th at all? But I got to keep it in standard form. So I'm going to go plus 0x to the 4th plus 12x cubed plus 2x squared. Let me go ahead and move this a little bit. Oh, not this guy. Let me move this guy. Plus 2x squared minus 9x plus 8. So always remember to write it in standard form. Why did you put the 0x to the 4th? Because I did not have an x to the 4th in this dividend. And I need an x to the 4th. I need to go in standard form. Sometimes I'm going to use that 0x to the 4th. Sometimes I won't, but I need to put it there. Now, how many times does x squared go into 5x to the 5th? X to the 5th divided by x squared. It's going to be 5x to the 3rd times. Very good. So this is 5x to the 3rd. Now distribute the negative to the product. 5x to the 3rd times x squared is 5x to the 5th. Very good. 5x cubed times 3x is? Okay. Plus 15x to the cube to the 3rd. Did I need this term in this particular example? Not, because it didn't give me an x to the 4th, but I like to have it there just in case so you could line it up. So now I distribute the negative. This cancels, and 12x cubed minus 15x cubed is negative 3x cubed. I drop the 2x squared, and then I'm going to continue. But before I do, does everyone see where I am? How many? Yes, sir, my brother. If, let's just say for giggles, that I would have come out with 3x to the 4th. Well, then I just would have added those two up, and it would have been 3x to the 4th. But that way you have a place to line it up. That way, if you get the x to the 4th and you don't see the x to the 4th, what I don't want you to do is accidentally add it to the x to the 3rd. See what I'm saying? That's why I do that. Thank you, my man. Okay, so how many times does does x squared go into negative 3x cubed? Yeah, negative 3x. Remember, guys, okay, I hear a lot of silence when I'm asking these questions. Do the math. How many times does x squared go into negative 3x cubed? It goes in negative 3x times. So this is negative 3x. Subtract the product. Negative 3x times x squared is negative 3x cubed. Negative 3x times 3 is negative 9x squared. Just 9x. Okay, distribute the negative. That cancels. Now pay attention here. Pay attention here. I've got a 2x squared and a 9x. Can I add those up together? No. So I drop down my 2x squared, but guess what? What's this negative 9x plus this 9x? 0. So I drop down my 8. Now how many times does x squared go into 2x squared? Goes in 2 times. Subtract the product. 2x squared plus 6. Distribute the negative. And my answer will be remainder 2. So I've got 5x cubed minus 3x squared plus 2 plus remainder 2 over x squared plus 3. Tedious little skill, tedious, but not that difficult. But you got to know how to divide quickly. You got to know how to distribute, and you got to be very cognizant of the negatives. Does that make sense? Any questions at all? I still see people writing. I want to make sure you got this, my brothers. Okay. Thank you. All right. Last but not least. Okay. We got something called synthetic division. Synthetic division is extremely powerful because it makes your life so much easier when you are dividing polynomials. The best use for synthetic division is when we explore something called the rational root theorem, or the fundamental theorem of algebra. And we need to use synthetic division to test different values, and we'll get there. But I'm just letting you know, this is not a one-stop shop. This is not, okay, we just see this skill for today and that's it. This is going to be persistently used throughout the rest of mathematics. Pre-algebra, pre-calculus, trig, calculus, calculus 1, calculus 2, calculus 3. Okay, so please be aware of this. In this particular case, for synthetic division, there are a couple criteria though, okay? First of all, you use synthetic division when the leading coefficient of the divisor is 1. So it can only be a 1 there, okay? 1. Can't have it any other way. Remember always to write in standard form and fill in missing values with 0. And there's one more thing that I messed up, I forgot to put. Not only do you need a leading coefficient of 0, but the degree of the divisor must equal 1 as well. Okay? So I can't have an x squared and use synthetic division. Doesn't work that way. I can only have an x. Not a 2x plus 5, not a negative 6x plus 7, but an x. X plus 4, x plus 15, x plus a half, x plus 9. I need the leading coefficient to be 1 and a degree of 1. Now, if you get the criteria, it's very simple. You're going to put a root here, and then you're going to put all of your coefficients in order. Now, how the heck do you get this root? You see this denominator here, guys? Set that equal to 0. So if I set x minus 1 equal to 0, what does x equal? Right. So my root will equal x minus 1 set equal to 0. So x equals 1 is my root. So for my root, I put a 1 here. Now I put the coefficients in order. X to the 4th has a coefficient of 1. X to the 3rd has a coefficient of negative 2. X squared has a coefficient of 1. X has a coefficient of 1. And then there is a constant of negative 1. Does everyone see where I got those numbers? Now, no, they're not going to cancel. You're going to drop the first number. Drop the first number. Now, multiply the root times this first number. So what's 1 times 1? It's 1. Now add. What's negative 2 plus 1? Negative 1. Now what's 1 times negative 1? Negative 1. What's 1 minus 1? What's 1 times 0? What's 1 plus 0? What's 1 times 1? What's negative 1 plus 1? 0. Now, last step. Do you see how you started with an x to the fourth here? When you do synthetic division, these are your coefficients, and you're starting with 1 degree less than the original. So this is going to be 1x cubed minus 1x squared plus 0x plus 1, and there's no remainder. So my answer is x cubed minus x squared plus 1. That's synthetic division. And we're going to do another one. So for synthetic division, what's really important is getting the root, making sure you write all the coefficients in order, and then remember, the first number you drop down. Then multiply 1 times 1, it gives you a 1 add. 1 times negative 1, add. 1 times 0, add. 1 times 1, add. And then when you rewrite your answer, you start with 1 less degree than the original degree of the problem. You with me? Okay. Let's look at this bad boy. First of all, what's my root going to be? What's my root going to be? Set the denominator equal to 0, guys. What's my root going to be? 9. Okay, now I got to write all the coefficients in standard form. So in standard form, this would be x squared minus 16x plus 70. So I have a 1, a negative 16, and a 70. Now I drop my first number, always. Now what's 9 times 1? What's negative 16 plus 9? Negative 7. Now what's 9 times negative 7? Negative 63. What's 70 minus 63? 7. Now I'm going to write my answer. But I started with a power of what? So my answer is going to be a power of? Huh? Well, okay, now I heard 1, 2, and x. Those were the answers you gave me. So let's do this again. What was the original exponent? What was the original degree of the numerator? A 2. A 2. That was the degree. When I rewrite, don't I have to rewrite with 1 less degree? So what is the degree of my first answer here? 1. So this is a 1x minus 7 plus my remainder of 7 over x minus 9. Talk to me, guys. I see a lot of faces out there that don't look happy. Talk to me. Yes, sir. I'm sorry, my man? Oh, because this part here, that's my remainder. 1x minus 7, and that's it. This is the remainder. This last number is always going to be your remainder. Thank you, my man. Sir. Okay. Well, I had the root here. This is the root. So my root was 9 because I set the denominator equal to 0. Then I looked at the coefficients in standard form. I have a 1 in front of the x squared. I got a negative 16 in front of the x. And then I've got a 70. Synthetic division, I always start by dropping the first coefficient. Now 9 times 1 is 9. Negative 16 plus 9 is negative 7. 9 times negative 7 is negative 63. 70 minus 63 is 7. I'm done. There's nowhere else to go. Now I rewrite my answer using 1 less degree than the original. So this is going to be a 1x minus 7. And then I have a remainder of 7 over x minus 9. That's my remainder, sir. Thank you for your honesty. Does that help? Thank you, my brother. Yes, sir. Yes, sir. No, it didn't have a remainder, not because the root was 1, but because I had a 0 here as a remainder. Thank you, my brother. Last but not least, yes, sir, my brother. Correct. Whenever you have your last term here, guys, as a 0, there's no remainder. Ever. Thank you. Good questions, guys. Thank you. Good teamwork. Okay. So now, what's my root? Yeah. Now, give me my coefficients in order. 2, 0. Do you have an x squared anywhere? You got to put the 0 for the x squared. Then -5 for the power of 1, and then -7 for my constant. Drop the 2 immediately. Now what's 2 times 2? 0 plus 4? 2 times 4? -5 plus 8? Positive 3. 2 times 3? -7 plus 6? What was the original degree of my numerator? So what's my degree of my answer going to be? So this is a 2x squared plus 4x plus my constant plus a -1 over x minus 2. And that's synthetic division. This is heavy stuff, guys, I know. But talk to me. Please, I'm here for you. Yes, sir, my brother. Okay. No, not necessarily. Remember, if I have a 0 as a if I have a 0 as a remainder, I don't have a remainder. But in this case, I had a -1 as a remainder. How do you know it's the remainder? Because it's the number that comes right after the constant. Does this make sense? Promise? All right. Thank you very much, guys. Hope you learned a lot. God bless you and have a great day. Bye-bye.